for my monitoring system to load. Testing, testing. Hello, hello. Uh-oh. I might have messed something up. Let me see. Oh, wait. Okay. I hear audio. That is good, that is good. Good morning, good evening, good afternoon, and good night. I hope everybody's day is going well. Today, we are continuing on part 3 of Chapman piloting seamanship and small boat handling. I know nothing about boats, but I'm gonna read a book about it, I guess. That's not what that means. We previously finished off on page 27. Moving on to page 28. Page 28 is titled Boat Construction. Recreational boat building underwent a revolution about 40 years ago. Until the late 1950s, the principal material used in boat building was wood. A major change started when polyester resins and glass fiber became accepted as durable and economical materials. Within a few years, almost the entire small craft industry switched to molded plastic construction, which continues today to be the standard method. Wooden construction placed severe limitations on the designer. On the other hand, it allowed the boatwright, which is the craftsman boat builder, wide latitude to express his taste and expertise by manipulating the material. Fiberglass, or fiber-reinforced plastic, molding has created exactly the opposite situation. Molding allows designers unprecedented freedom to express their ideas in both structure and style, but it requires minimal skill on the part of the workers. The leveling effect on the craft of boat building was soon apparent. This effect is also apparent in the losses to our boat building vocabulary. Words such as carlin, C-A-R-L-I-N, or bearding line, for example, no longer have meaning in the context of boat construction except among wooden boat aficionados. However, there are enough wooden boat enthusiasts and enough wooden boats that many novice boaters may someday find themselves experiencing the unique pleasures of replacing a rotted plank or varnishing a vast expanse of brightwork, which is a boat's wooden trim. For that reason alone, the language of wooden boat construction is worth preserving. However, there is also a practical side. The terminology of wooden boat building helps to provide a more thorough understanding of the much newer vocabulary of fiberglass construction. And I believe I am going to turn my volume up a bit. Before moving on to the next section, on this page we have a photo. It looks like a workshop filled with, I don't know if we consider it lumber. Thinner planks of lumber, that's how I'm going to word that, and it looks like a bare, a unpainted wooden boat in the background of the photo, and then a half of a unpainted wooden boat in the, I'm gonna call it the foreground of the photo. I'm not sure on photography terms. They are all just bare planks of wood. No paint, no lacquer, no color. There's like toolboxes and stuff in it. And the caption states, on wooden boats, frames, also called ribs, oh, that the frames, are set into the keel at right angles, then covered with planking. These boats are carvel or carvel planked runabouts. Each continuous line of planking along the hull from bow to stern is called a strake. I am going to drink some tea. But no worries, it's cold season. This is to be expected. Moving on to our next paragraph. Our paragraph is titled Wooden Boat Terms. Larger wooden yachts built in North America before World War II were built in Carvel's construction. Separate planks were fitted to the frames or ribs of the boat. Each plank was butted or buted flush with its neighbors to perform a smooth no, that is not what that says. With its neighbors to form a smooth outer surface. Slight gaps between planks were sealed by caulking, with a fiber and tar compound called oakum. After the boat was launched, the planks would swell, tightening the seams. At the same time, a large number of mostly small craft were produced using a Scandinavian method of overlapping the planks called lap strake construction. This method yields a boat with a noticeable step at each lap. A strake, strake, in the context of these wooden boats, is a continuous line of planking. Planks were held together with copper clench nails, giving rise to the term clinker built as an alternative description for this construction. Factories built large numbers of boats up to about 30 feet in length, upside down, on jigs. A jig is a dimensionally correct framework that holds the parts in position until the hull is strong enough on its own to be rolled over and completed. Extremely well-defined series production methods allowed pre-war boat builders to turn out a consistent, cost-controlled product for a large market. Larger yachts, particularly those built as a one-off contract, would be built right side up in stocks. The keel would be laid, then the frames erected on it. Planks would be attached starting simultaneously at the gunwale with the sheer plank and the nope with the sheer plank and at the keel with with the sheer plank and at the keel with the garboard. Each plank might have been rabbeted, given a shoulder along both edges to allow a more secure fit, and a gap wide enough for caulking. The last plank, usually installed near the turn of the bilge, was known as the shutter plank. Joints where frames met on the keel were reinforced with roughly triangular pieces called floors or floor timbers. In a ballasted sailboat, floor timbers supported the long keel bolts, holding the exterior ballast keel in position. A substantial and carefully fitted timber at the bow, the stern accepted the plank ends and tied them together. The stem was usually reinforced to the frames by another triangular piece called a breast hook. The deck was formed by beams with a slight convexity known as camber or camber. I have no idea which one. Fore and aft stiffness was provided to the deck by carlins, which might also accept the boat's hiding. No, that is not what that says. Which might also accept the boat's holding important deck fittings, such as a mooring bit, BITT. The deck itself might be planked and caulked, or made of plywood covered with canvas waterproofed with paint. I am going to drink some more tea. One moment, please. And we are back. Next paragraph, well, that's not really a paragraph. Next section is titled From Planking to Plywood. In the late 1920s, wooden boat building began to see some influence from aircraft construction, which was then also executed largely in wood. Wood. In fact, many early airplane builders began their trade by crafting lightweight, high-performance racing boats. Improved glues resulted in plywood receiving respect as a secondary boat-building material. But it was not until after World War II that cold molding became accepted in the marine world. Cold molding involves thin, flat strips of wood that are laid diagonally over a male mold. Additional layers are applied at about right angles to previous layers until the desired thickness is achieved. Each layer is set in waterproof glue, resulting in a strong, lightweight, stressed skin hull that has little need of interior framing. In recent years, this process has been further improved through the use of epoxy glues. World War II brought large-scale use of sheet plywood in boat construction that was quickly adopted for civilian craft. Plywood was inexpensive, strong for its weight, and easy to use. Its major drawback is that it can be curved in only one physical plane. It can be formed into a cylinder, but not a sphere. I still don't know how to say this word. Hard-chined hulls or hard-chinned hulls. The word is spelled Chined. Fortunately, the switch to plywood coincided with the availability of cheap, powerful engines. The shaping limitations of plywood forced the creation of hulls with box-like hard chines. But these proved ideal for high-speed planing performance. The nation's waterways quickly ugh. The nation's waterways quickly filled with amateur-built boats brought to life from the pages of motorboating, rudder, popular mechanics, and other do-it-yourself. Oh, those are all commas. Brought to life from the pages of motorboating, rudder, popular mechanics, and other do-it-yourself magazines of the late 1940s and 1950s. Hard-chined boats are equally easy to build in steel or aluminum. Both of these metals are used extensively in larger yacht construction. Modern, modern, modern epoxy coatings enable the steel or aluminum to be encapsulated to prevent electrolysis or corrosion. With notable exceptions, few production builders have chosen to mass produce metal boats. Steel and aluminum generally have been reserved for the serious amateur or for the custom one off customers. Nope, that's not what that says. Or for custom one off construction. We have a photo. It appears to be a black and white photo of the underside of a boat on a car jack. The caption states, it's the same word. Oh well. A chine, the sharp angle at which the sides of a boat's hull meet the bottom, provides this deep V powerboat with better control and a dry ride at planing speeds. I'm gonna be honest with y'all. I will be honest with you guys. I do not know how that corresponds with this photo. Our next section is titled, The Shift to Plastic. Then came the chemists, with several drums of thermosetting resin, a few cans of catalyst, a curing agent, some bolts of white glass fiber cloth, and a mold. Just about anybody could get into the boat building business. Early molded boats with fairly timid limitations of carvel planked wooden holes. Carvel planked wooden holes. Since no one was really sure how strong fiberglass was or how long it would last, most builders erred on the side of safety. The result, as we noted today, was overly heavy hulls that were almost indestructible. Current fiberglass hulls are much lighter in weight and much less likely to suffer cosmetic deterioration, yet still appear to be as indestructible as their overbuilt predecessors. The principal advances in molded construction, at least for boats on long production runs, involved the use of I'm telling you, English is my first language. It's the only language I know how to speak. I know how to read. Involved the use of rigid foams or balsa wood cores. Fiberglass is strong but heavy and not very stiff. Sufficient panel stiffness can be achieved by separating two layers of glass with a light but compression-resistant core. Core construction, also called composite construction, is now almost universally used in many areas of hulls and decks. The structure might also be stiffened by the use of box sections called hi-hat sections, forming a grid or running longitudinally inside the hull or deck. Other advances have been made in gel coat formulation to provide a glossier and more color-retentive surface. Gel coats and barriers have also been formulated to prevent osmosis, the movement of water through the gel coat that eventually produces blisters. A typical mold schedule or list of layers consists of a gel coat, possibly an osmosis barrier, alternating layers of matte, which is cloth made of irregular short fibers, regular fiberglass cloth, and roving, which is stiff, coarse woven cloth. And occasionally, chopped strand sprayed onto the surface by means of by means of a pneumatic gun. This series of layers might be followed up by by the core material and further interior layers. Each layer is laid up or hand rolled into place against the highly polished surface of a female mold. Secondary parts of the boat are also molded out of fiberglass, usually with a simpler schedule than is used for the hull. The major parts are lifted from their molds to receive various fittings and equipment, such as cleats, winches, hatches, rails, windlasses, tanks, and electrical harnesses, before they are assembled into the boat. Before moving forward, we have a photo. I'm gonna be honest with you, I can't tell what. Oh, wait, no, I figured it out. So, this photo shows what appears to be a boat being lifted out of the female portion of a mold. That's what I'm gonna say it is. The caption states, fiberglass construction allows multiple hulls, superstructures, and other components to be made economically from reusable molds. Surfaces can be of any desired compound curvature. In addition, plastic hulls resist attack by marine organisms, but they do require anti-fouling paint. Our next section is titled The Hull Deck Joint. The chief engineering problem, once the molding is complete, is the chief engineering problem once the molding is complete is how best to attach the deck to the hull. Theories abound, but in general, the best hull deck joints offer large surfaces for bedding compound or other sealers and adhesives. Thick wood or metal bearing plates for through bolt attachments and a box-shaped section for stiffness are also requirements. Finally, there must be provision for rub rails, and stanchion bases. Molded construction is also used for one-off high-performance racing boats, both power and sail. While the methods used are similar to production boats, one-off projects make more use of better materials such as unidirectional, biaxial, and even more specialized glass cloths. Epoxy resins often replace the polyester resins used in conventional boats, and reinforcing materials other than glass fiber, such as Kevlar and carbon fiber, are used. In terms of industrial design, today's a molded boat can be considered a great success. An extremely durable, strong, and safe product, it costs far less than the equivalent vessel built of wood, and it has brought to boating a much larger group of owners than was ever contemplated in the days of the boatyard craftsman. Now, before we move on to the next section, we have another photo. Actually, this one is more of a diagram, if I do say so myself. How would I describe that? Basically, it shows two sections coming together with a screw that has an anchor on it going through it. The labels on the photo are from top left moving down, then top right moving down. It says fiberglass mat and roving, pointing to one of the sections. It said, which is probably the layered thing they put in the mold that they were talking about. Metal, pointing to what I would probably call an anchor for the screw, was on the outside so it stays in place and whatnot. I am not a carpenter. I just use the screws and the plastic pieces that come with it sometimes. The top right, it says rigid foam core or balsa for one of the sections going to be jointed together. Nope. I'm going to say put together. Joined, not jointed, joined together. Stainless steel, pointing to what I'm calling a screw. It's probably not a screw. For all I know, It could just be a stick of metal they're putting in to hold it together. And then in the middle of the bottom section to be put together says rigid foam core. Now, the caption of the photo states, hull deck joints must be rigid and watertight. Most are molded box sections that are liberally caulked with adhesive sealants. Stainless steel through bolts provide additional security. This hull deck joint is appropriate for a small powerboat. Moving on. This next section is titled Sailboat Masts and Spars. While carbon fiber is also used in the construction of sophisticated racing sailboat masts, the majority of modern sailboat spars are made of extruded aluminum alloy. Most masts and booms, the horizontal spar at the base of which is usually the mainsail, are simple tubes. When most efficient shapes are no, that's not what that says. When more efficient shapes are required, they can be fabricated by cutting and rewelding basic extrusions. Aluminum is strong, so mast failures are rare except on board hard-pressing racing boats. Its main advantage, however, is the material's lightweight, which keeps the boat's center of gravity low and improves sailing performance. Many replicas of older ships now carry aluminum spars that are dressed to look like either steel or wood. Page 31. Page 31 is titled Decks, Fittings, and Lines. The deck is an important structural part of the boat. Its design dictated as much for strength as by aesthetics. It is particularly true of sailboats with deck-stepped masts that are supported entirely by the deck. Fortunately, the nature of molded fiberglass construction allows naval architects to achieve strength through the shape, curves, and angles of the deck, as well as through the materials used. Beauty can be functional too. In wooden boat construction, decks are horizontal, while superstructures, such as the deck house or trunk cabin, are vertical. Everything is separate pieces held together by fasteners and caulk. Fiberglass construction. I'm going to drink some tea. One moment, please. Okay, where were we? Fiberglass construction allows deck and superstructure to be blended into one seamless part. A trunk cabin seldom projects more than 18 to 24 inches above the surrounding deck. A small doghouse or raised section may be added to provide standing headroom inside. This combination is typically of many This combination is typical of many sailboat designs of the 1950s and 60s. A true deckhouse, common on sportfish and convertible power cruisers, provides full stand-up headroom and is large enough to enclose the main saloon. The open expanse of deck forward of the superstructure is known as the foredeck. This is where anchor handling equipment will normally be found. Together with a that's not what that says. That is not what that says. Together with a Samson post, a stout wooden or metal bit around which an anchor rod or tow line can be attached. If the boat has a trunk cabin, side decks will lead aft to the cockpit. safety demands that the walking areas of all exterior decks be treated with non-skid material. Our next section is titled Fittings and Equipment. The fittings and equipment that the novice boater must learn to use depend on the nature of the boat. This can be illustrated by two modern boat types: the high-powered sport runabout, and the high-performance racing sailboat. The sport runabout is almost bereft of anything that might be called deck hardware. Its deck is a gleaming sweep of plastic with hardly any indication that the boat might ever be tied to a pier. A close look will likely reveal a couple of cleats, which are fittings with outward curving arms or horns, designed to accept a mooring line or loop of a lanyard tied to a fender, a pneumatic cylindrical cushion that protects the boat's side when docked. The racing sailboat, on the other hand, can seem to have no other purpose than to carry hardware. Like a display in a well-stocked marine supply store, it has a bewildering variety of blocks, clam cleats, line stoppers, and snap shackles. The difference between the two boats is that, in the case of the sport runabout, the engine is self-contained and normally hidden from view. Open the motor box, and the complexity of this type of boat is immediately apparent. The racing sailboat, by contrast, is a kind of wind engine, entirely open to view. The complexity of this boat is on deck, not hidden below. In both cases, the hardware is linked to its means of propulsion and appropriate to the boat's intended purpose. Our next section is titled Making Fast. Making fast is the nautical term for securing a line. Rope cut, which is rope cut for a specific purpose. To a cleat or other fitting. That was a sentence. Moving on. Most often, it is the proper term to describe tying the boat to a pier, a wharf, or even a tree on shore. With a small rowboat, this can be as simple as taking a painter ashore and looping it over a bollard, which is a painter. A painter is a light line, usually permanently fixed to a ring bolt at a small boat's bow. Painters are adequate for a ring boat at a I just read that. Painters are adequate for making fast small craft like dinghies. For making fast small craft like dinghies. Making fast a boat where am I at? Only slightly larger and heavier presents challenges. Dock lines must be carefully placed, even for a stay of only a few minutes. Starting with the smallest auxiliary sailboat or outward runabout, every vessel needs well-made hardware properly placed for the purpose of making fast to a pier. Deck cleats must be substantial and through-bolted, with a backing plate under the deck. A single large cleat is often installed near the center of the foredeck of small cruisers. It serves as both a docking cleat and a fitting to secure the anchor line. I am going to drink some more tea. Okay. Most builders install two cleats near the stern, one on each side. The one closest to the pier normally gets the work. Additional cleats are often placed along both gunnels about 1/3 and 2/3 of the boat's length from the bow. These cleats are useful for spring lines, also called springs, that control the boat's lateral movement along the pier. While a good quality, well-installed deck cleat is adequate for making fast on the dock. Nope, for making fast in a dock. It is not intended for towing, which puts considerably more strain on hardware than making fast to shore. Larger and heavier boats, often fitted with a forward Samson post, the best of which extend through the deck and are attached to the keel, become an integral part of the structure. If one does not go down to the keel and is bolted under the deck, a strong backing plate must be used on the underside. A horizontal Norman pin goes through the Samson post to prevent a line from coming up and off the post. And while we are here, there is also a photo. The photo appears to be the front portion of the boat that also has a metal, I'm gonna call it a guardrail. It probably isn't called a guardrail. And it has a few lines. It has a few lines coming off of it. The caption states, the foredeck should provide a secure pulpit, strong stanchions and lifelines, and a tow rail to brace against. Cleats on a boat not equipped with a Samson post must be strong enough for anchoring and for any towing. Fittings on this racing sailboat have been chosen for their lightweight and not their strength. Page 32. Ooh. On this page, we start with a photo. I have no idea what that is. I have no idea what that is. It's some metal thing that looks like exposed metal on top of a painted white boat. I couldn't tell you what that is. However, the caption states, oh. The Samson post, a strong fitting on the foredeck, secures the anchor rod or docking lines. The normal pin, which passes through it, keeps lines from riding up and off the post. Our next section is titled, Staying on Deck. Rails are installed around the sides and ends of the deck to prevent crew members from falling overboard. They may be of metal tubing or plastic-covered stainless steel wire. These are supported by stanchions along the gunnels. Sailboats and some powerboats will have pulpits made of metal tubing on the boat. Nope, that is not what that says. Made of metal tubing on the bow and sometimes at the stern. Handrails on trunk cabins and at other locations aid in moving around safely. A solid barrier at the deck edge on larger boats is a bulwark, usually topped by a cap rail. At the stern, such a rail is a taffrail. Smaller craft that cannot support bulwarks often have tow rails to keep an errant foot from slipping. Tow rails are made of teak or special aluminum extrusions. Sailboats often use socket tow rails as attachment points for hardware. Some sailboats have special eye bolts installed at various locations around the deck where crew members can secure the tethers of their life harnesses. A life harness keeps the wearer attached to the boat even during an accidental slip overboard. An alternative to eye bolts is a plastic-coated stainless steel wire running from bow to stern in the middle of the deck known as a jack line. It allows the crew free movement fore and aft without the need to unclip their tethers. Our next section is titled, Other Deck Fittings. A variety of equipment in addition to fittings for making fast or adjusting rigging is found on boats. Other deck items range from hatches and windows to ventilators and windlasses. A boat more than 30 to 45 feet, or 9.1 to 10.7 meters long, especially if frequently at anchor, is generally fitted with a special type of rotating drum, which is called a windlass. This mechanical device handles the heavy work of retrieving an anchor and a long rode. A windlass is usually powered by hand or an electric motor, although some larger units use hydraulics. Fenders are essential to protect the top sides against damage when securing to a pier or rafting alongside other boats. There are always fenders, never bumpers. Fenders, never bumpers. Fenders are rigged from the gunnel or lifelines on lanyards. Setting them properly is a skill that must be acquired, even though most boats are equipped with a rubber rail, a protective metal strip, often with a metal cap or vinyl insert, along the gunnel or lower on the top sides of a rubbing strake. Okay, I think I'm good. Because of a boat's small space and constant dampness, ventilation is an issue. Air must be let Air must be let in, but water kept out. One of the best solutions is a dorade vent. It is spelled Dorade, vent, named after a famous racing sailboat. A dorade is a cowl atop a two-part box, a box with a barrier in the middle. Air flows over the barrier, but water is trapped and allowed to drain back out. Smaller nautical windows are called deadlights when they what? Smaller nautical windows are called deadlights when they cannot be opened, and port lights, often just called ports, when they can. Some port lights have metal covers to keep water out and should. I'm at least doing an hour today, okay? I really am trying. Some port lights have metal covers to keep water out should the glass break. Larger windows are too large to be called port lights. They are just windows. I am going to drink some more of my tea. I feel like all I've done so far is drink tea. I think I said a word wrong. I know I said a word wrong. Where was it? I know I said a word wrong. No cap. Oh, so they didn't put it in before. Okay. Our next section is titled Protecting Lines from Chafe or Chaff. I'm gonna say chafe because to me chaff is that stuff when you're processing wheat. So I'm gonna say chafe, like chafing stuff rubbing together. Mooring lines should be protected from chafe whenever they run across the edge of a deck. Metal rubbing strakes do this while still allowing the rope freedom to move fore and aft along the gunnel. In some cases, such as with an anchor rode, movement of the rope along the rail is not acceptable. Then the line is kept in place by a special fitting called a chock. The smooth surface of this metal fitting lessens chafe, while its horns force the line to remain in position. Chafe can be a problem despite chocks or rubbing strakes. Boats are always moving, even when made fast to a pier, and this motion causes ropes to wear. Protective chafing gear is often fitted to mooring lines, where they pass through the chock, Nope, where they pass through a chalk or over an obstruction. Chafing gear might consist of plastic hose split to slip over the rope and bound to it, or heavy canvas wrapped around the rope in a way, uh, in in the way of the chafe. We have a photo of what appears to be a thickly braided nylon rope hanging over the side of a boat. Like you threading a needle, it's hanging over like side of a boat, kind of like that. And about a third of it in the photo seems to be covered or separated and stuck inside a smooth cylindrical surface or item. That is how I will describe this photo. The caption states, chafe guards should be used on any lines that pass over an abrasive surface. They may be a purchased item as above, but can be homemade by using slick garden hose or special tape. Now I believe I will start the next section, but we're not going to get through it. It should not take me this long to read. Is this still chapter 1? I think this is still chapter 1. Hold on. This whole thing is still chapter 1. You know what? We're going to be here for a long time. Continuing on. Our next section on page 33 is titled Mechanical Propulsion and Steering. Except for sailboats under sail, recreational boats are driven through the water by propellers. Directional control steering is through a rudder on or no, that's not what that says. That is not what that says. Is through a rudder or, in the case of outboard and outboard powerboats, vectored thrust. Unlike cars, there is no standard number of engines for a boat. Many power cruisers have 2 sets of engines, propellers and rudders. A small number have 3 engines. Some even have 4. Propeller basics. A propeller is a rotating helical device that changes the rotational power of the engine into either forward or reverse thrust. In the early days, propellers were thought to pull themselves through the water, much like a wood screw pulls itself into a plank. That gave rise to the term screw as a synonym for propeller. A twin screw vessel is one that has 2 propellers. In nautical slang, propellers are also sometimes known as props or wheels. Propellers are usually classed Propellers are usually classed by the number of blades, direction of rotation, diameter, and pitch. For example, a 3-blade or 13 by 19 turns clockwise which is in forward gear, is 13 inches in diameter, and theoretically travels forward 19 inches in one rotation. Therefore, the pitch of the propeller is 19 inches. However, some forward distance is always lost to slip. In order to create useful force or thrust, a propeller must have a slip angle because the tip of each blade travels a larger circle than the root near the propeller hub. This means that the tip is moving much faster than the root, so it must have a smaller angle to achieve the same amount of forward motion. That's why a propeller blade is twisted from its root That is why a propeller blade is twisted from its root at the hub to its tip to create the required slip angle. A propeller blade in cross-section is shaped to act as a foil. a curved surface that creates a force by moving through either water or air. Other foils on boats are sails, keels, and rudders. As the blade rotates, it divides the stream of water passing over it, creating two forces, lift and drag. We have a photo. The photo appears to be the underside of a boat in the water, or correction, the underside of an item in the water that appears to have a propeller on the back of it. But because I think it's supposed to be active, I can't see what's in the water. And the caption states, the caption states, the caption states, propellers move a boat in the water much, nope. Propellers move a boat in the water using much the same principle as sails in the wind. Curved foils, the blades, create a pressure difference, low pressure on the forward surface and high on the aft. The foil shape is intended for forward rotation, one reason propellers are less efficient in reverse. Our next section is titled Propeller Efficiency. Whoops, how does the... Yeah, that works. Sailors constantly trim their sails to match boat speed and wind conditions. Trimming involves changing the angle of the sail relative to the wind and changing the actual curve of the sail. In theory, the same sort of trimming should be done with a propeller blade to match the amount of thrust needed. In fact, variable pitch and adjustable pitch propellers have been developed, but most of the propellers in use are fixed pitch. Variable pitch propellers are designed with blades that can be pivoted by the operator to change their pitch during operation. These are expensive, complicated, and seldom seen on yachts. Adjustable pitch propellers are similar, but nope. But the pitch cannot be changed by the operator while underway. A fixed pitch propeller has a factory installed pitch that is not changed to meet operational demands. Instead, a pitch is chosen that allows the engine to reach maximum safe revolutions per minute, the RPM, under the anticipated load. Blade area is directly related to the amount of horsepower that a propeller can handle. In general, the more horsepower available per pound of boat, the greater the required blade area and pitch. If additional horsepower needs to be applied, the diameter and blade area are usually increased and the shaft speed rotation is reduced. If the blade tips spin too fast, the propeller will begin to cavitate. Tiny low-pressure bubbles in the water collapse against the tips with enough force to actually pull metal out of the blade. If it continues long enough, cavitation will destroy the blade tips, reducing shaft speed by increasing pitch and blade. Oh, cavitate like cavities, okay. Oh. Reducing shaft speed by increasing pitch and blade area is usually fixed for this problem. Ventilation is a different condition that is often confused with cavitation. It results from the propeller running too close to the surface of the water. When a propeller ventilates, the engine races while forward thrust is lost. Power from the engine is transmitted through a transmission and propeller shaft similar to those in a car. The transmission has a clutch mechanism, forward and reverse gears, and may have reduction gears to reduce the speed of the propeller shaft without slowing the engine. The shaft exits the boat through the shaft log, which keeps water out while still allowing rotation. And before we end, there is a photo on this page. It appears to be a propeller by itself, not attached to anything. And the caption states, "The adjustable pitch propeller answers the need for greater efficiency through a wide range of speeds." And I hope you all have a great morning, evening, afternoon, and you will hear me next time.